All right, so now we're going to talk about more trigonometric functions. It's just going to be a continuation of what we did before and some practice with it. All right, so find the exact value of sine inverse of sine of 5 pi over 4. So remember, we're trying to decide, is that in my restrictions? So sine is from negative pi over 2 to pi over 2. So let's plot 5 pi over 4. 1/4, 2/4, 3/4, 4/4, 5/4. So that's not going to be in my restriction. So I have to do a little bit more work with that and figure out what is the sign at that value. And the sign, it's a y value, it's negative. Everything's negative in the third quadrant. So that's negative square root 2 over 2. So then I'm going to ask myself sine inverse of negative square root 2 over 2. So basically, at what angle does sine equal negative square root 2 over 2 within my interval? Okay. So the answer to that, first of all, it's got to be negative. So it's going to be in my fourth quadrant right here. And it's going to lie on one of the fourths because that's where we get the square root of 2 over 2. So going backwards, that's going to be negative 1/4. And we'll write that as negative pi over 4. Okay. All right, find the exact value of sine tangent inverse of 1/2. All right, so it's already drawn the picture for you here, which is pretty nice. Okay, so tangent inverse of 1/2. So opposite over adjacent is 1/2. Okay, and if this square root of 5 wasn't given to you, you'd have to use Pythagorean theorem to get there. Okay, now, so that's the angle that we're talking about. So we want sine of theta. Okay, so how do you find sine of theta? It's going to be opposite over hypotenuse. So 1 over square root of 5. Again, if there's an issue with it being in the radical being in the denominator, you can multiply by square root of 5. And you get square root of 5 over 5. And that would be your final answer. All right, next one. Find the exact value of sine inverse of negative 1/3. Okay, so here, sine inverse of negative 1/3. So here we have negative, and I'm going to go ahead and mark this as a negative 1 right here. So opposite over hypotenuse was 3, and again, you'd have to use Pythagorean theorem. We're going to do one where we have to draw the picture ourselves in a second for the next example. So negative 1 and 3. And then I want the cosine of theta. So it's already given me the angle, and then I want to find the cosine of theta. And so that's going to be adjacent over hypotenuse. So that will be 2 square root 2 over 3. And that's it. All right, next one. It says cosine inverse of negative 1/3. All right. So cosine inverse of negative 1/3. So we're going to keep it within our restrictions. So that means that it's got to be in the second quadrant, not the third. So therefore, I'm going to go adjacent over hypotenuse. Gives me cosine. So now I'm going to go ahead and I'm going to find my third side right here. So that gives me 1 plus x squared equals 9. X squared equals 8. And if you simplify the square root of 8, you can also see it in the previous example. That will give you 2 square root 2. And that's going to be positive because I'm going up. Okay? So then tangent. I want tangent of theta. And I'm going to go ahead and mark theta on my diagram. Tangent of theta is opposite over adjacent. So if I'm looking at theta, opposite of theta is 2 square root 2 over adjacent is negative 1. Let's simplify that to negative 2 square root 2. Okay? All right, inverse secant, cosecant, and cotangent. This is not really that essential, but I do just want to at least show it to you. So secant is going to be the same restrictions as cosine, with the exception that it cannot equal pi over 2 because we know there's going to be an asymptote there. Cosecant is the same restrictions as sine, but it cannot be 0. Where are we at? Yep, it cannot be 0 because there's going to be an asymptote there. And cotangent is just going to be the same. It's going to be one kind of period of that. So it's going to be between 0 and pi instead of tangent, which is between negative pi over 2 and pi over 2. Not super essential, because I'm going to show you kind of a way to think about it that you can always refer back to sine, cosine, and tangent. So not super important that you know those restrictions. So this is what I'm talking about. I'll show you right here. Cosecant inverse of 2. So I'm looking basically for cosecant of x. Where does cosecant of x equal 2? Okay. So you can rewrite this, though, cosecant inverse of 2 as sine inverse of 1/2, because we know that sine and cosecant are reciprocals of each other. Okay? So then I know how to do sine inverses. I look at my unit circle within my restrictions for sine, and I say, where does sine equal 1/2? Well, that's going to be right there at pi over 6. Okay, so don't worry so much if you can convert between cosecant and put it into the form of sine. Remember, they're reciprocals. Just flip it. 2 over 1 turns it to 1/2. All right, so these you can use your calculator on. You obviously have to use your calculator on. Secant, cosecant, cotangent, and cotangent. Now, here's the key, though. It's like what I just said, is that there's no secant button, cosecant, cotangent button on your calculator. You have to put them in terms of sine and cosine. So instead of secant inverse of 3, we're going to have to type in our calculator cosine inverse of 1/3. Again, still in radian mode. We're going to have to type in sine inverse of negative 1/4. Tangent inverse of 2, and tangent inverse of negative 1/2. Okay, so I'm going to do this to 3 decimal places just because that's what we're used to. So here we get 1.231. Hopefully you paused it and tried it yourself. Negative 0.253, 1.107, and negative 0.464. All right, so for these examples, I'm going to go through the odds real quick, and then I want you to practice on the evens and check your answers. All right, so these are going to be without a calculator. So sine inverse of 1. So I'm going to sketch out my unit circle. Where does sine equal 1 between those two values? That's going to be up at the top of my unit circle, which is at pi over 2. All right, we just did this example here. Sine inverse of 1/2. Well, 1/2 is right there on my unit circle, and so that is going to be at pi over 6. All right, this one's a little bit more complicated. It says tangent inverse of negative square root of 3. I think we actually did this one too already. So tangent inverse, those restrictions are negative pi over 2 to pi over 2, but we don't include those two endpoints. So I know I have to be in quadrant 4 because it's negative, okay? And you have to divide sine and cosine. So square root of 3 over 2, negative 1/2, and 1/2 negative square root of 3 over 2. So I'm going to use this guy down here, okay? 1/2, 1/2 negative square root of 3 over 2. So sine over cosine, negative square root of 3 over 2 times 2 over 1, keep, change, flip, and I get negative square root of 3. So I'm looking at that angle closest to the bottom. Okay, so I'm going to zoom in a little bit. So remember, this was negative 1/6, this was negative 2/6. So negative 2/6 I can write as negative 1/3 or negative pi over 3. All right, number 7 is something we haven't seen before. This arc just means inverse. So this is cosecant inverse of 2. All right, so cosecant inverse of 2, remember, go ahead and rewrite that as sine inverse of 1/2. Okay, we've already evaluated sine inverse of 1/2. That's the same as number 3. That's going to be pi over 6. All right, secant inverse of negative square root 2. So that's going to be cosine inverse. All right, remember this is over 1, so that's going to be negative 1 over square root of 2. Now that doesn't really look familiar, like something I've seen on the unit circle before, but let's rationalize it, and it should look more familiar. So times square root of 2 over square root of 2, and I get negative square root of 2 over 2. So I'm looking within my restrictions for cosine, which are 0 to pi. Where does cosine equal negative square root of 2 over 2? So it's got to be to the left, and that's going to be at 3 pi over 4. All right, number 11. This time you have two things to do. So first we have cosine inverse of 1/2. So where does cosine equal 1/2? I'm going to go over here. Within my interval, where does cosine equal 1/2? So I have two choices because it's got to be positive. This is my long one, this is my tall one, so the x is going to be shorter here. So it's going to be at pi over 3. Okay? So when cosine equals 1/2 right here, I'm then asking what is the sine value at pi over 3? And the answer is square root of 3 over 2. So the coordinate here is 1/2 square root of 3 over 2. That's your ordered pair. All right, number 13. Okay, so how we can do this one? So it says secant of negative pi over 4. So this one's going to kind of go back. So secant of negative pi over 4. So let's write this out. So negative pi over 4 is going to be right down here. And I want to find the secant there. So let's write out this ordered pair. So it's square root of 2 over 2, negative square root of 2 over 2. So secant, remember, is 1 over cosine. Okay, 1 over cosine. So at negative pi over 4, secant of that is going to be, I'm just going to basically flip this value. So it's going to become 2 over square root of 2. Let's rationalize that and just make it a little bit cleaner. Times square root of 2 over 2. So I get 2 square root 2 over 2. I can cross these out and I get the square root of 2. Okay, so this part right here on the inside equals the square root of 2. All right, we're not quite done. We have one step left. So then it says secant inverse of the square root of 2. All right, so secant inverse of square root of 2. So I'm going to rewrite that as cosine inverse of 1 over square root of 2, because remember I can just flip that. Again, that doesn't look familiar, 1 over square root of 2, so I'm going to rewrite that again. I'm going to rationalize it. So square root of 2 over square root of 2 equals square root of 2 over 2. How many times can I say 2 in a row? All right, so I have cosine inverse of square root of 2 over 2. All right, so I'm asking myself cosine inverse of square root of 2 over 2 within my interval 0 to pi. All right, so I know my x has to be positive, so I got to be over here, and square root of 2 over 2 is going to be at pi over 4. Ooh, that was a fun one. All right, I am going to go through all 15, 16, and 17 because those are a little bit more complicated. All right, so these are going to involve right triangles. So it says cosine of tangent inverse of x. So I'm going to go ahead and draw a right triangle. So tangent inverse of x. So it doesn't really matter where you put your theta, but I'm going to put it on top just for consistency's sake. So tangent inverse of x. So I know tangent is opposite over adjacent. So I'm going to write this as x over 1. So opposite over adjacent. So x divided by 1. All right, now when I have two sides of a right triangle, I can find the third side using Pythagorean theorem. So I'm going to call that side c. So c squared equals x squared plus 1 squared. Take the square root. So c equals square root of x squared plus 1, because 1 squared is just 1. So that's my hypotenuse, is x squared plus 1. Now, what is the cosine of that angle? So cosine is adjacent over hypotenuse. So adjacent side is 1. Hypotenuse is square root of x squared plus 1. So my final answer is just 1 over the square root of x squared plus 1. Because 1 on top represents my adjacent and the bottom represents my hypotenuse. Alright, remember this arc right here represents sine inverse of x. Okay, so whenever you see it with x, you're going to draw your right triangle. Not like that. Alright. So, draw my theta. Alright, so sine inverse of x. So opposite over hypotenuse. So opposite is x over my hypotenuse is 1. So 1 squared equals x squared plus, let's say, b squared. So 1 minus x squared equals b squared. So b equals the square root of 1 minus x squared. All right, so how do you find tangent? Tangent is opposite over adjacent. So opposite of theta is x. Adjacent to theta is the square root of 1 minus x squared. And that's it for that one. And last one. So I'm going to draw my right triangle. Here I have cosine inverse of 3x. So first thing I'm going to do is draw in my theta, and then I have adjacent over hypotenuse, 3x over 1. And then I'm going to set up Pythagorean theorem. 3x, make sure you put that in parentheses, squared plus b squared equals 1 squared. So that gives me 9x squared. Make sure you square both the 3 and the x. So b squared equals 1 minus 9x squared. And then take the square root. So square root of 1 minus 9x squared. Alright, so I want the sine. Sine is opposite over hypotenuse. Now in this case, my hypotenuse is 1. So I'm going to divide by 1. So square root of 1 minus 9x squared over 1. But I don't really need that over 1. So it's just 1 minus 9x squared. Okay, so that gives you a little bit of practice. Make sure you go back and try those evens on your own and check those to get some practice with that, but that gives you a little bit more practice on inverse trig functions.